So hello, welcome to another video of chemo topic. So in this lecture, we are going to discuss about some questions regarding the steric number concept and how to find the hybridization, and then I will talk about how to find the geometry and structure and shape of such molecule after the calculation of hybridization. So in the last lecture, we have discussed about the steric number calculation formula, and for recapitulation, I have written over here that what is steric number. Steric number is basically the valence electron central atom, because we are always considering the hybridization of the central atom of a particular molecule, like the carbon center for methane molecule, the oxygen center for water molecule, and the nitrogen center for ammonia molecule. So the valence electron of central atom plus the number of side atom, but we have to take care about the fact that the side atom have to be monovalent, that is it have to form only one bond with the central atom. So the number of side atom and have to be monovalent plus charge on the system. If that is negatively charged, we have to add one electron because it is gaining one extra electron, and if it is the positively charged, then it is lacking one electron, then we have to subtract this term with 1. So divide by 2 because we are taking the pair of electrons. So this is the steric number, and we know if steric number is 2, that is sp hybridization. If steric number is 3, that is sp2, and steric number is 4, sp3, and so on. Okay, another formula we have discussed, the steric number equals to number of sigma bonds plus number of lone pairs, because we are considering both sigma bonds and lone pairs. And from steric number itself we can find out the hybridization, and from hybridization we can directly tell the geometry of such molecule, because geometry only depends on hybridization. Why I am telling so? Because hybridization, this formula of steric number contains both bond pairs and lone pairs, so we have to consider bond pairs and lone pairs both in case of hybridization formula. And geometry also defines the bond pairs and lone pairs both, because we have to consider both bond pairs and lone pairs in order to get the geometry of a particular molecule. So the geometry is depends upon the hybridization. If it is sp3 hybridization, if a molecule, then no matter what it has lone pair or not, the geometry always will be tetrahedral. And the another term is the shape and structure, because we often confuse these two terms, but these two terms are different from each other, the geometry and shape and structure. Because the shape and structure only consider the bond pairs, because it doesn't contain the sigma bond, it doesn't contain the lone pair of electrons, only the bond pairs are being considered. So if a particular central atom contains any kind of lone pair, any number of lone pairs, then the shape will differ from the geometry. We have discussed about the ammonia and water molecule. In the ammonia molecule, nitrogen has one lone pair. Due to that, the shape is altered from the geometry. The geometry was tetrahedral because it got the sp3 hybridization, but the shape was pyramidal. And same goes for the water molecule. For the sp3 hybridization, the geometry was tetrahedral, right? But the shape altered from the geometry, and we got the shape, or we can say the structure of water molecule, to be angular or bend shaped. Fine. So let's discuss about some of the examples. I have written over here some of the examples, and we have to calculate the hybridization. Okay. So from steric number we know. Let's calculate the steric number for methane molecule. This is question number 1. So for that steric number, we have to consider the valence electron central atom. For carbon, we know that the atomic number is 6. So 2, 4. So the valence electron is 4. Or you can do from the electronic configuration 1s2, 2s2, and 2p4. 2p2, sorry, and this is the valence orbital because it has the highest n value. You can see the highest n value is 2, which is the outermost orbital. So this is the valence electron, and number of valence electron 2 plus 2 equals to 4. So for carbon atom, the valence electron is 4 plus, we have to add the monovalent side atom. So here is the side atom is hydrogen, which is monovalent in nature. So number of side atom is 4 plus, if any charge is over this molecule, no, this is a neutral molecule, so we don't have to add or subtract any kind of electrons. Let's divide it by 2, and we will be having our steric number to be 4. And if the steric number is 4, it signifies the hybridization to be sp3, right? So the carbon atom, that is the central atom, have the hybridization to be sp3 for methane. Okay, so let's go to the next part. Okay, another thing, if the hybridization is sp3, then the geometry will be, if I talk about the geometry, that would be tetrahedral. I will give a chart about this later on, but let's first discuss about the hybridization calculation. Let's not consider the geometry over here. I will discuss it later. So for ammonia molecule, what is the valence electron? Number of valence electron for nitrogen? We know nitrogen atomic number is 7, so 2, 5, or we can consider like this one, 1s2, 2s2, 2p3, and it is the valence orbital, n equals to 2 is the outermost orbital, and total number of valence electron is 5. So 5 plus number of side atom, which is monovalent 3 hydrogen, so we have to add 3 divided by 2 because it is a neutral molecule, equals to 4, and 4 steric number 4. So this column is suggesting steric number. So steric number 4 means the hybridization to be sp3. Okay, so let's come to the third question. It is quite easy, and now you can solve this. If you get afraid of the term that it contains sulfur, which is not a second period element, then you don't need to worry about it, because you know where the sulfur lies in the periodic table, because it lies under the sulfur. So number of valence electron of oxygen, you know the number of valence electron of oxygen, that is 6, right? The atomic number is 8, so 2, 6, so the valence electron is 6. And for sulfur atom as well, the valence electron will be 6, because if we go down with respect to one group or one column in the periodic table, the valence electron will always be same for such molecule. That is, if we consider nitrogen and phosphorus, let's suppose, you know that valence electron of nitrogen is 5 and the valence electron of phosphorus will be 5 because it is lying under the nitrogen atom. So if we look down in the periodic table and if we have an idea about the molecule, then we can easily find out the valence electron, the number of valence electron, and that is super easy. So for sulfur, we know the valence electron is 6 because it lies under the oxygen atom, plus number of monovalent side atom is 6 because fluorine is monovalent, 6 divided by 2 as it is a neutral molecule. So the steric number comes out to be 6, which defines the hybridization to be sp3 4, and we have to add 2 because we don't have any p orbital, we have to include the d orbital. So the hybridization will be sp3d2. Let's come to the another question. It is the question requires the phosphorus valence electron. We know the phosphorus lies under the nitrogen atom in periodic table, so the valence electron of phosphorus will be equal to the valence electron of nitrogen, and we can calculate the valence electron of nitrogen. We know that 2, 5, so 5 is the valence electron of nitrogen and the phosphorus will be same, so 5 plus number of monovalent side atom, chlorine is monovalent, so we have to add the number of there are 5 Cl atoms, so we have to add 5 divided by 2 equals to 5. So if the steric number is 5, we can definitely say the hybridization to be sp3, and we have to add another d orbital, so the hybridization will be sp3d. Okay, so for the next part, it is asking for the hybridization of XeF4. So for xenon, okay, so it is a difficult task because xenon lies in the 18 group, right? This is a 18 group, and it is called the noble gases, group of noble gases, or we can say the inert gases. And for the noble gases, you have to remember that always the valence electrons will be 8. Why? That for helium, the valence electron is not 8, this is 2, but for neon, let's suppose neon is 10, so 2, 8. So the valence electron is 8, and all of the inert gases or noble gases lies down the neon, then helium, neon, argon, krypton, xenon. If we talk about all of the noble gases, then the valence electron will be exactly same with the neon because it lies under the neon atom, so the valence electron will be 8. So any of the inert gas will have the valence electron 8. So for the xenon as well, number of valence electron will be 8. plus number of side atom which is monovalent. For fluorine we have to add 4 because they are monovalent. No charge, neutral, so divide by 2 we will be getting 6. So 6 means sp3d2. It is quite easy, right? The next question, it contains the XeF6. We know the valence electron of xenon is 8 because it is noble gas. So 8 plus number of side atom which is monovalent 6 divided by 2. So we will be having our steric number to be 7, which implies the hybridization to be sp3d3. Yes, for sp3 there are 4. We have to add again 3 d orbitals. So the hybridization will be sp3d3. For XeF2, let's suppose you can do it by your own. So the valence electron will be 8 plus side atom which is monovalent 2, fluorine 2, neutral molecule divided by 2. So the hybridization will be 5. Sorry, the steric number will be 5. Implies the hybridization to be sp3d. Okay. For ClF3. Okay. So for ClF3, the central atom is Cl. So the number of valence electron for halogen, how many? 7, right? Because it lies before the noble gas. For noble gas, you can say like this one as well. It will be easier. BeNOF and neon. Right? And if we talk about the groups, it is 16th, 17th, 18th, 15th, 14th, 13th. Now if we talk about the valence electrons, we have to subtract it by 10 because 13 minus 10, subtract by 10. Okay, so 13 minus 10 will be, okay, let's write over here, 13 minus 10, 14 minus 10, 15 minus 10, 16 minus 10, 17 minus 10, and last of all 18 minus 10. So the valence electron for the boron series will be 3, for carbon series will be 4, nitrogen series 5, oxygen series 6, halogen series 7, and the noble gas series 8. So it will be quite easier to remember that if we have to calculate the number of valence electron, we just have to subtract it by 10, the group number. So we will be having all the valence electrons. So for Cl, it is halogen series, so the valence electron will be 7 plus number of side atom which is monovalent 3 fluorines, we have to add 3. Now this is a neutral molecule, so divided by 2 and 5. So the hybridization will be sp3d. Let's talk about the I3 minus. So for I3 minus, because only I is present, we have to consider the central electron to be I, and it is a halogen, so the valence electron will be 7 plus. Except the central atom, there are 2 more ID, so which are monovalent. So we have to add 2, divide by 2. But if you are not considering the charge, then you are doing wrong, because it is not a neutral molecule and it is negatively charged, so we have to add 1 electron as well. So we will be getting the steric number to be 5, and which implies the hybridization to be sp3d. For the next question, it is asking for the IF5. First, steric number calculation, you know that for iodine, central atom is iodine, and the valence electron to be 7 plus number of side atom 5 fluorine, which are monovalent. So 7 plus 5 divided by 2, as it is a neutral molecule, so equals to 6, and which implies the hybridization to be sp3d2. Okay, let's solve some other. So let's solve some of the questions. So first question is asking for the hybridization of xenon and in XeOF4. Now just focus on these, that there are 2 types of atoms which are in less number. So Xe and O is there. So what will be the central atom? Because you can get confused that here xenon can be the central atom as well as the oxygen can be central atom. So there are 2 criteria we have to focus on in order to find out what is the central atom in a particular molecule. First of all, the central atom will be least in number. in most of the cases you will find the central atom is in number 1, because in methane the carbon is in number 1 and 4 hydrogen, so the central atom is 4 is the carbon. First criteria, if there are two atoms which are in the least number, like the XeOF4, here xenon and oxygen both are in one number, but fluorine cannot be central atom in this case because fluorine has there are 4 fluorines. So first criteria is getting tied between the Xe and O, and then we have to look about the electronegativity, that is least electronegative atom will be the central atom. Electronegative atom will be the central atom. So in between Xe and O, which have the highest electronegativity, oxygen, so it can't be a central atom. In this case the xenon will be the central atom. So first we have to take about the least number will be the central atom. If we can't distinguish between by this factor, we have to look the electronegativity between the two atoms, and least electronegativity atom will be the central atom of that molecule. Okay, so let's do this question. So in XeOF4, the central atom is xenon, right? So number of valence electron in xenon is 8 because it is noble gas, plus number of side atom which are monovalent. Here oxygen is not monovalent because we know that oxygen is bivalent. Any kind of molecule we know, and oxygen is there, it will form two bonds. So this is oxygen is a bivalent in nature. So we can't add the number of oxygen over here in steric number. So we have to add 4 fluorine plus any kind of charge is not there. So divide by 2 and we will be having our steric number to be 6, and which implies our hybridization to be sp3d2. Okay. So for the next question, SO4 2 minus. So what is the valence electron for sulfur? Because it lies under the oxygen, so the valence electron will be 6. Here we can see 6 plus. Is there any kind of side atom which are monovalent? Because there are 4 oxygens and which are divalent, we can't add in the steric number formula. But here are 2 negative charges, so we have to add those negative charges in our formula. So by adding 2 and divided it by 2, we will be getting our steric number to be 4, which simply implies the hybridization to be sp3. Next come to the next question, which is asking for the BF3 molecule. So the central atom is boron and number of valence electron on boron is 3. Number of side atom which are monovalent, 3 fluorine, 3 neutral molecule, divide by 2, so 3, and the hybridization to be sp2. Next question, for xenon XeO2F2, we know the central atom to be xenon. The valence electron of xenon is 8 because it is noble gas, plus 2 oxygen we can't add in the steric number because those are bivalent, 2 fluorine monovalent, yes we can add, so 8 plus 2 divided by 2 because it is a neutral molecule equals to, we can get the steric number to be 5, which implies the hybridization to be sp3d. Next question, XeO2F4. So for XeO2F4 we know the central atom to be xenon, the valence electron to be 8, plus we can't add the number of oxygen because those are divalent, we have to add the fluorine, neutral molecule, divide by 2 equals to 6, the hybridization will be sp3d2. For XeO3, the number of valence electron of xenon is 8. Now we can't add the side atom number because 3 are oxygens which are bivalent and no charge, so 8 divided by 2 equals to 4, hybridization to be sp3. For BeF2, for beryllium, hydrogen, helium, lithium, beryllium, so atomic number to be 4 and 1s2, 2s2. So the valence number of electron is 2. So for beryllium, the valence number of electron 2, plus side atom which are monovalent fluorine 2, neutral molecule, divided by 2, having the steric number to be 2, and the hybridization is sp. For CS2, the number of valence electron for carbon is 4, plus any side atom to be monovalent? No, there are 2 sulfur which are divalent because sulfur lies under the oxygen. Oxygen is divalent, so sulfur is also divalent. We can't add any kind of charge on the system. No, this is a neutral molecule, divided by 2, and we are having the steric number to be 2 and hybridization to be sp. So now this to discuss about the geometry and shape, we know that the geometry and shape, or we can say the shape or structure, are different because in geometry we only we consider both the bond pairs and lone pairs, which is directly related to the hybridization, and for the shape and structure we have to consider only the bond pairs. So if a molecule contains the sp3 hybridization, it will have the geometry fixed to be tetrahedral, but the shape can differ depending upon the number of lone pairs. So first, for the methane molecule, we know the steric number to be, what is the steric number? So 4 is the valence electron plus 4 is the side atom divided by 2. So 4 is the steric number, hybridization is sp3, and for the sp3 hybridization it is fixed that the geometry will be tetrahedral, or we can write it over here TD. TD means the tetrahedral, and the shape will be also tetrahedral. Because why I am telling so? Because carbon atom don't have any lone pairs, because we know the valence electron, we have to consider the lone pairs, that the valence electron on carbon atom is 4, right? 6, 2 plus 4, so 4 is the valence electron, and all of the 4 valence electron are being utilized to form the sigma bond with the 4 hydrogen. So all of them are utilized to for the 4 hydrogen electrons in order to form 4 sigma bonds. So there are no valence electron left on the carbon atom. So the number of lone pairs on carbon atom is 0. Okay, so how to calculate number of lone pairs? You have to find out the valence electron of the central atom. Then you have to consider the side atom. Which of the valence electron of the central atom is being utilized to form the bonds with the side atom? If there are any left electron on the valence electron of the central atom, then that electrons will be considered as the lone pairs, because all of the 4 electrons of the carbon atom, which is the central atom of methane molecule, are being utilized in order to form the sigma bonds with 4 hydrogen side atoms. So there are no valence electron left over the central atom carbon, so the number of lone pairs for central atom carbon is 0. So all the bonding pairs will be there, so the tetrahedral geometry and shape will also be tetrahedral. Okay, if there are no lone pairs on the central atom, the geometry and shape will be same. So if I draw, this will look like this one. So the shape is also TD, tetrahedral. Let's come to the ammonia. So the steric number is the valence electron nitrogen 5, side atom 3 divided by 2, 4, and the hybridization is sp3. So the geometry will be tetrahedral because it is only depending upon the hybridization, so tetrahedral. But the shape will differ. Why? Because we know the valence electron of nitrogen atom is 5, right? And we have only 3 side atoms. So whenever we have to find out the number of lone pairs on the central atom, we have to consider all of the side atoms, whether it is monovalent, it is bivalent, it is trivalent. We have to consider all, because all are forming bonds with the valence electron of the central atom. We have to consider the electrons, valence electrons, which are being utilized in order to form the bonds. Then we have to subtract it to find out the lone pairs. So there are 3 hydrogens in ammonia, so 3 electrons. So from 5 electrons, 3 are being utilized to form 3 sigma bonds. But there are still 2 electrons left over nitrogen, and 2 electron means 1 lone pair. Yes. So in ammonia there is number of lone pairs, how many? 1 lone pair, because 1 lone pair means 2 electrons. 2 electrons are left over the nitrogen atom, so number of lone pairs will be 1. So from that we can surely state that the geometry and shape or structure will be different for the ammonia molecule. And if we consider the shape, something like this one we can draw over here. Okay, and we have to if we consider the lone pair like this one, the geometry is looking like the tetrahedral. It is tetrahedral in geometry, but in case of shape, we can't consider this lone pair because we have only to consider the bond pairs. And this is looking like a pyramid. I have discussed in the previous class. So this shape is called pyramidal. So I have to erase this part. And this shape is called pyramidal. Okay, let's come to the water molecule. The steric number is 6 is the valence electron of the oxygen central atom plus 2 for 2 hydrogen divided by 2 to be 4. Hybridization is sp3. That means the geometry will be tetrahedral for sure. Tetrahedral TD. And if we talk about the shape, it depends on the number of lone pairs. So how to calculate the number of lone pairs of the oxygen atom? We know the valence electron of oxygen to be 8, the atomic number is 8, 2, 6. So 6 is the valence electron, but there are only 2 hydrogen atom at the side atom. So they will contain 2 electron. So in the 6, out of the 6 valence electron oxygen atom, only 2 electrons are being utilized, because in covalent bond formation we know one atom gives 1 electron and the side atom gives another electron, and for one bond formation we have to get only 2 electrons. So from 2 electrons from the 2 hydrogen, 2 electrons from oxygen will form 2 sigma bonds. As we see in water molecule, 2 sigma bonds are there, but there are still 4 electrons left for the oxygen atom. So 4 valence electrons are left, and 4 valence electron means how many lone pairs? 2 lone pairs, because one lone pair contains 2 electrons. So on oxygen atom in water there are 2 lone pairs present. So the geometry and shape will differ. And what will be the shape of the water molecule? The water molecule we can draw something like this, HH, and to consider the lone pair we can draw it like this. So the geometry is tetrahedral. It's looking like tetrahedral, right? But for the shape we can't consider the lone pair, only the bond pair, and we can see this is looking like angular, like the compass. So this is called angular shape. You have to remember the name of the shape. So this is called angular shape, or it is called also bent shape, because it is a bent like structure. So then the shape will be angular shape and bent shape, but the geometry will be tetrahedral. For SO4 2 minus, we know the valence electron to be 6 because it's lying under the oxygen atom, plus there are no such monovalent side atom, but there is 2 electronic charge on the same system. So plus 2 divided by 2. So the steric number to be 4, corresponding hybridization will be sp3, corresponding geometry will be tetrahedral. But the shape can differ, because for sulfur we know the valence electron to be 6 in number. So for sulfur, valence electron equals to 6, and there are 4. So for sulfur the valence electron is 6. There are 2 charge on the atom, on the system, so we have to add 2. So the total valence electron for SO4 2 minus is 8. Number of side atom oxygen, and we know the oxygen is bivalent, so it will form 2 bond with the central atom. So each oxygen is providing 2 electron. Each oxygen providing 2 electrons. So 4 oxygens will provide 8 electrons. So oxygen side atom is providing 8 electrons. Total valence electron on sulfur is 6 plus 2. 2 comes from the charge of the system. So the 8 electrons and 8 electrons all are forming how many sigma bonds? Yes, there are 16 electrons, so 8 sigma bond, or we can say 8 bond. 8 bond. These are all not sigma bond, because 4 will be sigma, 4 will be pi. We can see from the shape that all of the valence electron of the central atom sulfur is being utilized in order to form the bond. So the number of lone pairs will be 0 on sulfur atom. So number of lone pairs will be 0. That means the geometry and the shape for the sulfate SO4 2 minus will be same. So the geometry will also same, and if we have to draw this one, we can draw like this. Okay, but here is it is wrong because we have to consider the two charge of the system as well. So we can remove this single bond, pi bond to be -1, this to be -1. Now it is clear that the geometry and the shape both are tetrahedral. Okay. Now next come to the ammonium ion, because it is a protonated form of ammonia, that is NH4 plus. So the steric number will be for nitrogen 5 will be the valence electron plus 4 is the side atom, which are monovalent hydrogen atom, and here is a positive charge of the system, so we have to subtract it because it is lacking one electron. Divided by 2 equals to 5 plus 4 9 minus 1 8 divided by 2, that is 4, and the hybridization will be sp3. The geometry corresponding to will be tetrahedral, that is Td, and the shape will be, because all of the, you can see over here that if a corresponding central atom is sp3 hybridized, then that can form 4 bonds, and here are 4 side atoms, so all the bond electrons are being utilized. It is a trick to find out quickly that all of the bond in NH3, we know this was the NH3 molecule, one was the lone pair, so here the lone pair is being utilized to proton to take the H plus, so here is another H, and all of them are bond pairs, so there are no lone pairs, so the shape will also be tetrahedral, and here is positive. Otherwise you can find out the lone pair as well, because for nitrogen atom the valence electron is 5 and plus 1 positive charge, so we have to subtract 1. Like the sulfate one, we have to add 2 electrons in the valence electron. The total valence electron of nitrogen atom is 4, and there are 4 hydrogen which provides 4 electrons, so all of the 4 electrons are getting utilized in order to form the bonds. So the number of lone pairs over nitrogen atom of nitrogen atom in ammonium ion, this is not ammonia, this is ammonium ion, is 0, and if the number of lone pairs on the central atom is 0, then the geometry and shape will be the same thing. So in the next class we will discuss several molecules like this one in this chart, and we will complete this steric number concept.